Hello, welcome to your weekly video. Given we had the exam and it just seems to make sense, we're going to keep this one pretty short this week. May mean a little bit longer of a video as we work our way into Friday of next week, but we also may shorten the discussions a bit in the upcoming week regarding weather, since it's going to be kind of quiet. Hopefully you enjoy some relatively warm weather, especially Saturday, looking kind of almost downright toasty compared to where we've been the last couple of weeks here coming the weekend. So enjoy some hopefully nice and maybe even a little bit of sun in terms of the weather. So we were talking when we ended class on Monday about the polar and subtropical jets. And so we've been basically dealing with a polar front jet situated well to our south. And that's why we've had cold Arctic type air for much of February. But as this jet has meandered back to the north, we've warmed up. And so we talk a lot about the jets and it being a gradient in relation to what type of temperatures are occurring near the surface. And so in other words, when you have a sharp boundary between warm air and cold air at the surface, this may translate into some type of a jet stream aloft. And so these are going to be more active in wintertime. We often are south of the polar front jet around here in Valpo when we have our coldest weather, and as this evolves north, we sometimes get to warm up. And so if we get on the right slide, we can move forward and look at a little bit of a 3D type schematic. Here we'd be looking at a jet, maybe moving, you can think of it from the front of the page towards the back of the screen here, moving across from west to east in the United States, warm air entrenched across the southern United States and Florida, cold air to the north in Canada, and between these two where we talked about that polar front, 60 degrees north, but again, that's in the idea of this model and not necessarily always where it's located. It does drift much further south than 60 degrees north, but the idea that cold air more dense and it's going to be a much thinner layer. This came up on some of your labs earlier this semester, whereas the warm air, less dense, expands. And so this difference causes a sharp change in some of our upper level heights related to temperatures, and where this contrast exists, we run into our polar jets. And so here you can see how these jets evolve across the world. Again, polar front jet situated further towards the poles than the subtropical jet. You can notice a lot of waviness, and we have schematic depicting lows where we have these troughs where the jet or the winds dip down towards the equator. You have these ridges or highs. Again, warm air domes lifting northward. And so you may recall it came up in lecture about a week and a half ago about how we kept getting persistent snowfall. And we had one of these troughs that had basically dug down here to Mexico and was lifting off the eastern seaboard. Florida was always on the warm side of our polar front jet, but we were entrenched, as was basically 2/3 of the United States. And so you may have heard of things such as the polar vortex in the news. The idea that this is kind of actually a little bit of a piece of that polar vortex. It's a multifaceted system. And so you see these troughs, little lobes of cold air that sometimes do get to dive pretty far south, especially when other features such as blocking patterns set up in our atmosphere. Subtropical jet, a little higher up. They're trying, I think, to depict that here, showing a little bit more of a gap between the Earth and the jet. A little higher up in the atmosphere, not nearly as intense as the polar front jet, and not necessarily the same harbinger of weather to come. There are other jets, other ones of interest. You have the tropical easterly jet. This is going to be a very, very high jet, up around 100-150 millibars, occurring in a different part of the world, Southeast Asia and Africa. And it's interesting in the sense that all of our jets that we've been showing move from west to east. This one counteracts that, moves from east to west. It's not, to be fair, particularly important for what we talk about here in Met 103, but it just shows that not all jets behave the same, and there's a lot of interesting nuances depending on where you are at in the world. The low-level jet, however, is extremely important at certain times of the year here in the United States. There's a number of low-level jets, but the one that we really focus on, the nocturnal low-level jet here in the United States, is notable in the sense that it occurs much, much closer to Earth's surface, a couple hundred meters. So we talk about, again, our pressure where it's about 1,000 millibars at the surface, and pressure is always going to decrease as you go up. We've talked about these jets way up here at 200, 300 millibars. The low-level jet is at about 850 to 950 millibars. It's pretty low to the ground. And so it's going to be a little weaker, and it's going to actually be important in the late afternoon and evening hours is when the low-level jet often kicks in, and we get some strong winds that'll come from the south to the north off the Gulf of Mexico. What this does is it helps to usher in some warm, moist air and also serve as a mechanism for creating thunderstorms. And so the low-level jet is one of those things that becomes quite important when we look to threats of severe weather. This will become more apparent as we get into severe weather and talk about terms such as shear or changing of winds as you go up in the atmosphere. But it's also very important in the sense that it brings that moisture further north and can help to trigger important thunderstorms for farmers that rely on periodic rainfall in order for crops to grow with at least minimal irrigation needs. And so these are important to basically ensure that we don't start developing drought conditions across much of the plains. Ocean currents, we've talked a little bit about ocean currents thus far. Here's another schematic showing the currents, which are an important part of our general circulation. Again, looking at the gyres themselves, basically you have warm currents that'll exist on the eastern side of our continent. So here's Kuroshio on the east side of Asia. You got the Gulf Stream current on the east side of the United States, and then you have the Brazilian current. Again, notice how these change direction. A warm current coming from the north, from equatorial regions here on the east side of South America. Conversely, you start to get full circulation, so we get that cold California current. Again, really going back to understanding why the weather is so different in San Francisco than, say, Richmond or Baltimore, Washington, D.C., which are affected by the Gulf Stream. And a number of these will become pretty important here as we talk about some other features, such as the Peru or the Humboldt current. The Peruvian current here is that cold air that's actually moving from areas closer to the poles or the South Pole up towards the equator, very similar to what you would get from the California current, just again the thought of moving poleward towards the equator. You can also see again, think of a big H in here and the circulation revolving around our subtropical highs. We haven't yet gotten into winds. We're going to start into that next week. To be fair, one of the tougher sections, but we're going to get into pretty good detail to help you understand the different forces that help to create our wind. And so you'll understand a little bit more by the end of next week about why air flows the direction it does around highs and lows. And so here's, if you look really close and are good at geography, we got New Jersey sketched in there, but you can see Maryland, you can see the Outer Banks of North Carolina. And so you get this warm air. These are sea surface temperatures. They list them here as brightness temperatures. But you're basically looking at that Gulf Stream, bringing that warm air further northward. And sometimes when it interacts with cold air, you start to see these gyres or spins that happen in the water. They're kind of neat to look at. This actually becomes very important, the Gulf Stream, when we start to talk later on about mid-latitude cyclones and the fact that we oftentimes get some pretty intense storms off the East Coast. The term nor'easter may be familiar to you depending on what you followed for weather at times in your lives, and some of these ocean currents are catalysts for the energy that we need, that latent heat that we need to drive the development of some of our mid-latitude cyclones. And so we'll kind of finish off things here talking a little bit about some oscillations and teleconnections. I'll go out on a limb and say everyone has at least heard of El Niño and La Niña. It's definitely one of those terms that makes it out into the world pretty regularly depending on what's going on, and chances are decent that if you've watched some news you may have heard the term La Niña thrown around very recently. Although it's not fair to say La Niña is responsible for what's happened over the past week. There's been a number of other features over the past month, I should say. The cold snap of air and the generational cold that was actually down in Texas. There's been a number of other features such as blocking and some other really fancy terms way beyond the scope of Met 103, like sudden stratospheric warming back in January. But we are under a La Niña regime. And so there is some understanding of weather that happens, sometimes some cold snaps in this area during La Niña, and the fact that the weather can change quite rapidly under El Niño type winters. Or La Niña, sorry about that. Anyways, El Niño and La Niña, and oftentimes referred to as ENSO, or the El Niño Southern Oscillation. El Niño became a household term, well, basically before you were born. 1997-98, there was newscasters that were basically calling for California to fall into the Pacific Ocean. We were just getting massive storm after massive storm, and very similar to what you've heard over the past number of years about the polar vortex, basically being the, for lack of a better term, scapegoat for all kinds of crazy weather. That was El Nino back about 20 to 25 years ago. El Nino is when those waters off of Peru, so you might have to toggle back a slide and look at that. Well, let's just do it. Toggle back and look at, wrong direction. Look at that Peru and Humboldt current, that cold air that's working its way up the coast, the west coast of South America. It ends up being abnormally warm. Seems pretty mundane. Who cares? The water's a little warm. Go for an extra swim. But it was noted years and years ago to happen around the time of Christmas, thus the term El Nino, the child. And what was happening is fishermen were experiencing issues related to the anchovy harvest. And they found that there was actually a relationship between guano, or bird droppings. You can't make this stuff up, folks. That they were able to relay to different fishing tactics, or different needs of different tactics that they had to use to be able to be good at what they were trying to do. And basically, birds that ate the fish would do different things, and it was all related to this warm dome of air, or dome of water at the top of the Pacific Ocean that was abnormal. La Nina is simply a reversal, where the coastal Peruvian waters are actually abnormally cold. And so the term El Nino Southern Oscillation is brought upon oscillation being basically a wavy, changey pattern. The idea that they were measuring pressure between the island of Tahiti and Darwin, Australia, and basically realizing that they would behave in opposite manners. As one would jump up, the other would fall down. And so this oscillation of pressure was pretty important and tied in with El Nino and La Nina. The reason we care about these is not because we're too concerned with bird droppings in Peru. We're concerned because of the term teleconnections. The fact that you can have weather in one part of the world affecting weather in another part of the world. The idea that these abnormally cold waters that are occurring right now off the coast of Peru and out into the central Pacific can influence things like the jet stream. They can cause the jet stream to be wavier or maybe a little stronger at times, and therefore affect weather in the United States or affect hurricane patterns. And it's pretty fascinating. We'll talk about the idea of teleconnections now and then, but teleconnections come up pretty regularly if you watch the news and want to learn a little bit about what's going on in different parts of the world, and are very important if meteorologists are trying to make long-term predictions. And so these are some graphics that show the idea of non-El Nino conditions at the top. Little tough to say that's a La Nina, but if you were to amplify this a little bit more, you would see La Nina, that cold water off the coast, versus El Nino here at the bottom, where you have the warm water. And so you can see this is going to promote warm air wanting to rise, so you see greater thunderstorm activity out here off the coast of Peru, sinking moisture out here by what's known as the maritime continent, Indonesia and parts out that way, as opposed to a normal time when there's rising air around Indonesia and sinking air. And so you can see the circulation in the vertical. You can see the air that would be moving from east to west along the equator at the surface, and then reversing in the vertical. And so we've talked early in the section about Hadley cells and Ferrel cells and polar cells that would fall from the equator towards the poles. Here we look at a east-west in the vertical, this Walker circulation. And so when we see a flipping of ENSO, we actually reverse the Walker circulation. And again, this becomes important because you're changing areas of rising and sinking motion and influencing the jet stream further north and how it may move into areas such as the United States. You see this term upwelling, the fact that if you have strong trade winds, you're basically pushing this water near the coast away, which allows much colder water from below to rise up. If you lose that, you basically allow the water to pool over time, heat up, and you push this thermocline, this boundary between the warm near surface water and much colder water below. You basically suppress that deeper and deeper down into the ocean. And so you can see how El Nino works over time. You're going to see times in which you have warm events that spike. For instance, I mentioned the 1997-98 year with El Nino. We've had one more recently in 2015 and 16, and often they get replaced, again, a strong El Nino, by a notable La Nina. As I alluded to right now, we are actually under a La Nina pattern, and we measure these by simply looking at sea surface temperatures over a relatively small area out in the middle of the Pacific and seeing how they behave. Right now, they're cold, and so we are in what looks to be the second year of a La Nina event. And so I end this section here on the Arctic Oscillation. The Arctic Oscillation is interesting. You see the positive Arctic Oscillation here to the left, and you see a negative version of the Arctic Oscillation here to the right. There's other ones here, the North Atlantic Oscillation, the Pacific Decadal Oscillation. There's all kinds of oscillations. But this one's interesting in the sense that we've been affected by this kind of negative Arctic Oscillation. We've actually had a notable negative NAO recently, and this has been related to that polar vortex. Sure, the polar vortex is all the time spinning around the poles. Vortex is an area of rotating air, and so this evolves through both layers of the troposphere as well as the stratosphere. But this is related. The idea that these pressure patterns that may exist out in the Arctic may actually impact things that are at much lower latitudes. And so we see, for instance, when these Arctic oscillations change back and forth, it influences whether we have cold air further south or whether it kind of sticks around further north. It impacts things like the storm track. And so we've had recently, well, some impacts with behavior that's occurring way up here in the poles and maybe over Greenland that's actually responsible in many ways for that deep trough and the record cold air that invaded the plains a couple of weeks ago. So again, the idea of things that happen in one region of the world can have pretty notable impacts in different parts of the world. The idea of teleconnections, and these will come up now and then as we work our way through the rest of the semester. All right, we kept it to under 17 minutes. Have a good weekend.